charged tapes. So the purpose of this lab is to create and observe the change in a previously uncharged piece of tape that later becomes charged in order to see, does it become positive, does it become negative, and then create a computational model to not only calculate this charge, but also the exchange of electrons that create a deficiency and the ratio of this deficiency. This lab uses a couple different fundamental laws, including Coulomb's law, Newton's second and third laws. Newton's third law is used to find the relationship between gravity and the electric force, because the forces have to balance each other out, while Coulomb's law is used to find the specific charge, because as you can see on the left here, it gives us a specific formula where once we know the actual force, we can go down and find the charge. Newton's second law is used with the gravitational calculations, because force of gravity is equal to mass times acceleration due to gravity. So for the result overview, as you can see here are all the values. I'm not going to necessarily read them out because it's not going to help anything. The tape repelled against the objects because it has a positive charge, and they have also a positive charge, so charges will repel each other. These are all the numbers for the magnitude of the electron force, the charge of each piece of tape, the deficiency of the electrons, and the ratio of the deficient electrons. But a potential source of error of the lab was not including air resistance, because we only included things like gravity and the electric force, but technically there could have been a small amount of air resistance that should have been included. So that is a potential source of error. Here are the initial conditions with 0.279 meters of tape with a mass of 0.053, and it moved a distance of around 0.05 meters. There's a second piece of tape that is a little bit larger than the first, but close to the same length. The third piece of tape was on the table in order to help give the other two pieces of tape a charge. The system is tape B, as you can see in the figure, and the surroundings are tape A, the earth, and basically everything else. So the procedure was to create the base tape, put it on the table, and put piece of tape A on it, and then rip it off really fast in order to create a charge, and the same with tape B. We determined the charge, if it was positive or negative, by hovering a plastic pin, and a book near it to see if it kind of attracts or repels in order to quantitatively find the charge. We set tape B on top of two tall objects, like seen right here, such as books, that create a small distance and bring tape A close underneath it to measure the distance it takes tape A to float. We use this distance as well as the mass inside the tape to find all the required calculations. Here's one example of the experimental calculations. However, the rest of them can be easily found within the code because they were calculated within the code instead of by hand. But here's one example of how we rearranged the gravitational force and the electric force in order to come down to Q. Here is the example of some of the calculations that I was talking about on the left and on the right, where the left has the results and the right has all the different actual calculations. You can see gravity constant, Coulomb's constant, Q1 of the electrons, mass of the tape, distance, all of those things, and then the electric and gravitational force calculations, the charge calculations, the electron deficiency, and the ratio calculation. And then I also initialized the objects in that little area below the ratio. Here's the code for part 2, where we now consider the charge as spread out across the tape instead of just being a singular point. These are the parts of the code that had to be changed with our own values and updated rather than just what was given to us. And as you can see here, the magnitude of the electric force was a little bit different than was initially calculated, as I'll discuss a little bit later. It's 1.43822 e to the negative fifth here, and significantly more than that at 5.1993 e to the negative fifth on here. So for the what if, the observations would remain the same if electrons were positively charged and protons were negatively charged, because opposites would still attract, similars would still repel, everything would just be opposite. The only difference is that if there's a negative charge, the excess versus deficiency would kind of switch. So if it's a positive charge, there'd be an excess of electrons instead of a deficiency of electrons. The Model 2 is more accurate than Model 1 because it doesn't make the broad assumption that the charge is focused at a single point, but it spreads it out a little bit more, which is closer to real life. and the magnitude, as we calculated, is a little bit smaller because it is distributed across the tape instead of condensed at one spot, as I showed a minute ago. Thank you for watching.